Hello, my name is Alexia Davis. My science teacher is Miss Tafili, and I'm going to be talking about the desalination process today. Freshwater is a scarcity that not many people have, but the only way to purify it, ways to purify it are thermal and membrane. Membrane is when you put it through a bunch of really fine and expensive filters to get all of the gunk out. But for thermal, all you need is heat to evaporate the water and purify it, and then catch it again into a clean jar. For my experiment, the problem was not enough clean drinking water, and my solution was I looked up different ways to purify water using thermal energy, since it's the least expensive of the two solutions. The experiment that I found only required a bowl, a jar, and then the water that you needed to be purified, and then I also had a ppm sensor to know how clean it was. My goal was to have 70% or more of the water purified, to have it less than 100 ppm, which is like standard water, and also to be able to see how long it takes, and hopefully take less than 8 hours. The first experiment that I did, I used golf balls as weights down on plastic wrap. So the plastic wrap was over the bowl, catching the water as it evaporated from a heat lamp. And so the water would evaporate into a small jar that's in the center to catch all the clean water, because heat naturally purifies things. This solution was easy to do, but one of the problems was that it took a long time. After only 6 hours, I barely had any water in there, and I couldn't really get a ppm reading. And it was salt water, so because I couldn't get a ppm reading, and there was too little water, I couldn't tell if it had been purified or not. So for my revisions, instead of doing salt, I did dirt, so you can see the contaminators more clearly, and you can know if it got purified or not. And instead, I used the heat lamp for 12 hours instead of 6 to double the time, so that I'd have more water at the end. In the end, we had about like an inch of water in a small jar, which is definitely a lot more than the first time, but not as much as I'd hoped. For this, there was also lots of extra waste at the end. When I took the jars out of the bowls, all that was left was some really, really foul-smelling dirt water that would be waste and would probably cause a lot more pollution if we had to use this way. The prototype took lots of time, had lots of waste left over at the end, which wasn't very good, and produced very little water. The only positive to my revisions was that the ppm sensor was able to get a reading, and it was 25 ppm. This is extremely good, and is the normal water that you drink at your house every day. So it purified very well. The conclusion is, to wrap this up, thermal energy is a great way to create clean drinking water, but it may not be the solution that the world needs. Because, one advantage is that I found is that this solution is easy to recreate and you can use home materials to make. But the disadvantages were that there was lots of waste left over, it took way too much time, and there just wasn't enough water. So unless you want to revise this and have it on a larger scale, it would not work.